Okay, the grade 11s and grade 12s. I'm having the what to call the redox reaction for grade 11. Grade 11, we're going to talk about the redox reaction. We'll talk about redox reaction. Okay, this will be uh, for specific for the grade 12s. This one's for grade 12s. But we started this topic in grade 11, where we start with the redox reaction. Then I'm having three types of reactions here. This is the first type of the reaction, which is ion exchange. The second one, acid base. The third one, which is the redox. Okay, the ion exchange, we can see here exchange of ions. So now an example, we have this example, that side I'm having Ba, which is 2 plus Cl minus, together with Mg2 plus and SO4 2 minus. So now this, we are going to exchange, this is how you're going to exchange the ions. So I'll be having the product on that side, magnesium is Mg2 plus together with the Cl minus. So in terms of ions, we normally do cross multiple. This one will come there. That is why you see it will be MgCl2 there, this one. And what about Ba2 plus SO4 2 minus? So these ions cancel out, then we'll be left with BaSO4. Okay, so this one is an ion exchange, that one is an ion exchange. So now acid base, talk about transfer of protons. So talk about transfer of protons. This is H. Now we transfer this H plus, then we get ammonium ion, then that will be Cl minus. So we can observe now there is no change in oxidation number. So there is no change in oxidation number. So this one I'm having Zn plus HCl, ZnCl2 plus H2 there. So now to explain this for grade 11s for now, just watch what I'm doing here. But for grade 12s, I know you are familiar with this. The oxidation number for the free element, there should be some rules here at the bottom. So it's going to be 0. We assign it to be equal to 0. So now the oxidation number for, I'm having HCl, this is H plus, this is Cl minus, plus 1, negative 1. The Zn2 plus, the Cl minus, the oxidation number is positive 2. This one is negative 1. So now looking to the Zn from 0 to positive 2. Now oxidation number is increasing. Positive 1, which is hydrogen, to 0, oxidation number is increasing. But if you observe, I'm having chlorine negative 1. The chlorine is going to be negative 1. So no oxidation number change there. So now the Cl, we are going to use it as spectator ion in the reaction. All right. So now redox reaction and oxidation numbers. The redox, meaning the redox, the reaction. So we have the two parts there, which is the red one, that will be the reduction there. So we're going to talk about the reduction. This one OX, that will be an oxidation. So the oxidation must be loss of electrons. Then what about the reduction? It will be gain of electrons. Remember, in grade 11, now we talk about the types of bonds. So we talk about the covalent bond, we have the ionic bond. So when you talk about transfer of electrons, especially this one of ionic bonding, this one is the sharing of electrons, ionic bonding, transfer of electrons between metal and non-metal. So we can have an example for that. The sodium chloride. Remember, the sodium chloride, I'm having sodium, which is the metal, then chlorine, which is the non-metal. So we're expecting to see the transfer of electrons. Okay, the sodium, we know sodium is group 1. So sodium is group 1 in the periodic table. So in the outer energy level, I'm having 1 electron. So this sodium, because it's positive, is going to lose an electron. The positive ones, they lose the electron. But the chlorine is group 7. The group 7 chlorine need 1 electron to do what? To obey an octet rule, which is the maximum of what? The maximum of 8 electrons. Okay, so because of the electrons are balanced, this one will cancel this one. So this sodium there, and also the chlorine, 2, 4, 6, 7. Now I'm going to have sodium ion, the side I'm going to have 2, 4, 6, 7, 8. So this sodium is going to transfer this electron to the chlorine. So now the chlorine ultimate is going to get a maximum of 8 electrons. So once we balance the ions, positive 1 and negative 1, they cancel one another. Okay, so basically this is what actually you're going to talk about if you refer to a redox reaction. Talk about transfer of electrons. What is a redox reaction? Redox reaction is the transfer of electrons. Okay, so now to define oxidation and also the reduction, we are going to make that an example whereby I can have an example like that one of sodium and also the chlorine. Or let me make an example taken from let me see, I can use this one. I can transfer of electrons. This is the definition of the redox reaction. So this redox reaction, I'm having Zn plus HCl. Then I'm having ZnCl2 plus 2 hydrogens. So now then the oxidation, it must be loss of electrons, or it can be oxidation. It must be in terms of oxidation number. So the redox reaction and oxidation numbers. So this one is an increase in oxidation number. I'm going to explain that one. The reduction is the gain of electrons. It must be the decrease in oxidation number. So oxidizing agent is the what? Oxidizing agent is the substance that is reduced or gain of electrons. Reducing agent is the substance that is oxidized or can be loss of electrons. Now, oxidation number of unbonded element, it must be equal to 0. An example here, this Zn is unbonded element is equals to what? Is equals to 0 for that matter. What about H2 there? This is 2 hydrogens. So this is equal to 0. If you want oxidation number for hydrogen, you divide by 2. You divide by 2. Hydrogen will be equal to 0 there. So this is how we assign the oxidation numbers. So the second bullet, the sum of oxidation number in a compound, it must be equal to 0. So there's an example there which is ZnCl2. Now let me make an example by using that one. ZnCl2, I'm having ZnCl2. I want oxidation number for Zn. So because there's no ion there, so unbonded element, so this one, it will be the compound, it will be equal to 0. So I want oxidation number for Zn. So it will be Zn plus 2 chlorine. So this is equal to 0. Because I want the oxidation number for Zn, Zn plus 2, chlorine is group 7, then now it's -1 in terms of ion. I'm having 0 there. So Zn positive 2 multiplied by this is -2 is equals to 0. So Zn, it must be positive 2 there. So this is how we calculate the oxidation number for Zn. Okay. Or the shortcut by doing that, if you look at an example here, Zn, it will be in terms of the ions, Zn2 plus Cl minus. So now in terms of ions, oxidation number for Zn, so it will be Zn is equal to that ion, which is positive 2. What about the chlorine? Is equal to that ion, it will be -1. So you need to follow the rules here. You just follow the rules. If I have an example of let me make another example. I'm having another example. I'm having HSO4 minus. So I want oxidation number for sulfur. So because there's an ion, there is H plus sulfur plus 4 oxygens is equal to that charge, which is -1. But now if I'm having H2SO4, I want the sulfur, there's no charge, so this one is going to be equal to 0. But if you see the charge there, it must be equal to that charge. If I'm having SO4 2 minus, I want oxidation number for sulfur, I'm going to say SO4, it must be equal to that charge, which is -2. I can calculate oxidation number for sulfur. So now oxygen is group 6. 8 minus 6 is 2. I'll be having 4 oxygens minus 2. Sulfur, oxygen is -2, -2. Then we can calculate sulfur there. Okay. Then I'm having the oxidation number line. So oxidation number of atom only change during the redox reaction. So now there's a decrease in terms of oxidation number, -1, -2. These numbers are decreasing. If you go to the left, go on this side, we talk about oxidizing agent on this one, Ra, oxidizing agent, and also reducing agent increases. Okay, let me explain oxidizing agent and reducing agent. If you have O there plus O there, so this is equals to R. This side, we're going to talk about what is a reducing agent. Then I'm having R plus R is equals to O, which is oxidizing agent. So the first O is for oxidation. This one is for oxidation. The first O, oxidation. Then the other O there. The other O there, it stands for that oxidized. Oxidized. So don't forget this. So oxidation, oxidized, reducing agent. We go back to oxidation is the loss of electrons. Then now, in terms of oxidation number is an increase in oxidation number. Okay, this one is the reduction. R is for the reduction. Those numbers, they were reduced. I'm going to show you that they were reduced. So this one is oxidizing agent. Look at the definition of oxidizing agent. This is oxidizing agent is the substance that is reduced. Oxidizing is the substance that is reduced. The substance that is reduced, or can be gain of electrons. What is the reduction? Reduction is the gain of electrons. You see that? Reducing agent is the substance that is oxidized. Reducing agent is oxidized, meaning oxidation, it must be the substance that lose electrons, which is oxidation, loss of electrons. Okay, so now remember the example that I started with, the one of sodium. To get this, sodium is going to lose the electron. Sodium is going to lose the electron. What about the chlorine? The chlorine, it must gain that electron. Chlorine need one electron so that it can do what? To get maximum of 8 electrons. So this chlorine is going to gain an electron. From where? From sodium. Sodium is going to lose that electron. So once the sodium is going to lose electron, it will appear as sodium behave like a neon. If you look at neon, the atomic number, it should be 10 there. So once it's going to lose, remember sodium, this is 1123. So now this sodium, once it's going to lose electron, it will behave like a neon. A neon is a group 0. So it's the last group in a periodic table. It's inert gases or group 0. So now this last group, this element are stable. So meaning once it's going to lose the electron, it will appear, now the sodium will behave like a neon. Okay. Same applies to chlorine. The corresponding element to the chlorine is somewhere there. So you look at the last group there. Once it's going to gain electron, so now it will be behave like that element, which is corresponding period with the chlorine. So it will behave like that element there. Okay, so now let me explain this. So there is an example here. This one is a nice example. Zn, I'm having H plus, Zn2 plus, the hydrogen 0 there. So I want to now to put, okay, these are oxidation numbers. Oxidation number of embodied element is 0. That one H is positive 1. Then this one is positive 2. This one is 0. So you look at from 0, Zn to Zn2 plus. So is it the number increasing or decreasing? these numbers are increasing. So now Zn to Zn2 plus, it simply means now I'm losing 2 electrons. You look at this arrow there, Zn to Zn2 plus. So now it's an increase in oxidation number. It's an increase in oxidation say number. But in terms of electrons, it will be loss of electrons. So this one, it will be an oxidation. Okay, let's look at this one. Positive 1 to 0. Positive 1 to 0. These numbers are decreasing. Positive 1 to 0, the numbers are decreasing. So now will be 2H plus, then 2 electrons, then I will be having H2 now as a gas. So because the electrons were balanced, must be 2 electrons. If you cancel these two, if you cancel this electron and that electron, I'll be having Zn. This reaction will be Zn plus 2 hydrogen ion. This side I'll be having Zn2 plus, then I'll be having H2 there. So the first reaction, this one, it will be an oxidation. This one will be the reduction. So the reduction meaning hydrogen is going to gain electron, the Zn is going to lose the electrons. That will be oxidation and the reduction. So let's look at the summary here. So Zn2, this is 2 half reactions. Okay, this is 2 half reactions. Oxidation number of Zn increased from 0 to positive 2, increasing 0 to positive 2. Zn atom are oxidized. So meaning this one are oxidized. So Zn atom, so this one is an atom, lose electrons and form Zn2 plus ions. So it's going to lose electrons to form that ion. So Zn is oxidized and therefore is a reducing agent. So what about the other side? Oxidation number of hydrogen decreases from positive 1 to 0. The hydrogen ions are reduced. Positive 1 hydrogen ions are reduced from positive 1 to 0. These numbers were reduced from positive 1 to 0. Then hydrogen ions gain electrons and form hydrogen molecules. So now they talk about hydrogen molecules, and then hydrogen ions are reduced and are, we call the what? Are the oxidizing agent. So remember to remember the oxidizing agent, we said R, the first R, the second R, so it will be O. R plus R is O, which is oxidizing agent. So reduction, reduced. So oxidizing agent. Let's look at oxidizing agent. The oxidizing agent, this is where reduction is the decrease in terms of oxidation number. So it's the decrease in oxidation number from positive 1 to 0. So in terms of oxidation number is the decrease. But in terms of electron, I've gained 2 electrons. Gain of electrons. So you look at the arrow on the left hand side, once we have plus 2 is the gain of electrons. So these numbers were reduced. Oxidizing agent is the substance that is reduced from positive 1